Hi, welcome back. Some common redox reactions are combination, displacement, and combustion. You can have combination of elements or combination of a compound and an element. Let's go ahead and see how each one of these types can be a redox reaction. Our task is to assign oxidation numbers, and the rule says that the oxidation number of atoms in elemental form is always 0. Halogens have a -1. And potassium has to be +1 because this is a neutral compound and the whole thing has to add up to 0. And you can see how the oxidation number of potassium went up. So it's oxidized, while oxidation number of chlorine went down, so it's reduced. So therefore it's a redox reaction. Similarly with aluminum and oxygen combining together to get aluminum oxide, you know oxygen is -2, so this becomes -6, +6, aluminum's +3. You can see that the aluminum oxidation number increased, so it's oxidized, while oxygen decreased and it's reduced. You can pause the video and prove to yourself that combination of nitrogen and hydrogen is also redox. You can see hydrogen, according to the rule, it's +1. +1 times 3 is +3, and that's why it's a -3. Here you have 0, 0 again because they're both elements. Chlorine is -1, so this gives you a -3, and this has to be a +3 divided by 1. Phosphorus is +3. So we can see that the phosphorus is the species that got oxidized, while chlorine got reduced. We can also prove to ourselves that the combination of a compound and an element is a redox reaction. I like to do the easy stuff first. All the elements are 0. According to the rules, oxygen is -2. Here, nitrogen gets a +2 because -2 plus 2 gives you 0. Here, you actually have -4 because there are 2 oxygen atoms, so I must give +4 for nitrogen divided by 1 is +4. So the oxidation number of nitrogen went up from 2 to 4, so nitrogen was oxidized, while oxygen is reduced, going from 0 to -2. The second type of reaction is decomposition, and if you heat mercury oxide, this, by the way, is a symbol for heating, and you can see again -2, +2. Mercury went from +2 to 0, so mercury was reduced, while oxygen went up, so the oxygen is oxidized. Displacement reactions are also redox reactions, and here I'm showing displacement of a hydrogen from water, and I'd like you to think of water as this, where hydrogen is attached to the oxygen. So think of this hydroxide as one unit, and what happens is that aluminum picks up the hydroxide ion from the water, and hydrogen is displaced out as hydrogen molecule here. So if I were to do the oxidation numbers, the elements get a 0, oxygen is -2, hydrogen is +1, and that's because of the rule for oxygen and hydrogen. Now hydrogen here is +1, 1 times 3 is +3, oxygen is -2, -2 times 3 is -6, so aluminum will have to be +3 to balance it out. So here's +3. And you can see how aluminum was oxidized from 0 to +3. And hydrogen went down from +1 to 0, so hydrogen was reduced. The metal can also displace metal. Here is an example where zinc metal is displacing copper. So the oxidation number for zinc in elemental form is 0. You can immediately see that zinc was oxidized and copper went from +2 to 0. So copper is reduced. Finally, the combustion reaction. This is butane, which is the fuel used in cigarette lighters. When it combusts, it forms carbon dioxide and water. I can easily show that oxygen went from 0 to -2, so this was actually reduced. and the carbon is oxidized. Okay, I now want to go on and show you how we can use this kind of thinking to help us balance the chemical equations. First, pause your video and write these steps down. To help you figure out what the coefficients are in balancing a chemical equation, you want to assign the oxidation number to all the elements in the reaction. From the changes in the oxidation number, identify the oxidized and reduced species. Then you want to compute the number of electrons lost in the oxidation and gained in the reduction from the oxidation numbers. You can draw tie lines like I've been doing in this video. Multiply one or both of these numbers by appropriate factors to make the electrons lost equal to the electrons gained, and then use the factors as balancing coefficients. You can complete the balancing of the equation by inspection. It is extremely important to realize that the reducing agent loses electrons and the oxidizing agent gains electrons simultaneously. Let's go ahead and do an example. You have copper plus nitric acid forming copper nitrate, nitrogen dioxide, and water. The first step is to assign oxidation numbers, and from the changes in oxidation numbers, identify oxidized and reduced species. So we're going to go through this fast. This is -2, this is -6, this is +1, this is +1, so this one has to be +5. -2, pull out the nitrate separately. So this is -2, -6. This has to be +5 so that it adds up equal to the charge. So now you know that nitrogen is +5. 6 oxygens, 6 2s are 12. 2 nitrogens, that's 10. So copper will have to be +2. -2, and this is -4. This is +4. So this nitrogen is +4. -2 for oxygen, +1 for hydrogen. Let's create some tie lines and see what's oxidized and what's reduced. So I can see that copper is oxidized, which basically means it's a reducing agent. And that means copper would have lost electrons. And this time we want to figure out how many electrons it would lose. It would lose 2 electrons. So that's important to note. The second one is I want to follow the nitrogen, and I think I'm going to have to go over here, and I realize that the nitrogen is reduced, so it's an oxidizing agent, and it gained 1 electron. Having decided that you need 2 electrons, you want to put a 2 here because this is the product of the reduction process. I'm going to explain more on balancing a redox reaction in another video. This is not the complete story because you can see that if you decided to put a 2 here and a 2 here, it's not going to be balanced. The only thing we can tell by assigning oxidation numbers and determining the number of electrons lost and gained, it helps us decide the coefficient of species that do not contain hydrogen and oxygen. So more on this later. Thank you very much for listening. I will see you in my next video. Goodbye.